But let's start off with some astronomy. What's the Sun been doing? Yes, the Sun is becoming more active again. As Professor Bennell said earlier on, the solar cycle is actually quite a low one this time, but we have had some activity recently, and the Sun is sort of warming up. There are more spots visible on the disk. But unfortunately, it's not like it used to be. Not like the old days, I remember, when the Sun was completely pockmarked with spots even at maximum. We're really not getting that kind of activity. Maximum probably next year, maybe, or the year after, but it's not going to be a big maximum. But take advantage of looking at the Sun over the next few years, because it may be on a downward path after that. The one thing that's really impressive these days is the kind of images that solar observers manage to get. This is a Pete Lawrence image of a particularly interesting thing which the solar observers call a philoprom, and that's because physically when these things are seen on the limb they're called prominences, and when they're seen on the disk they're called filaments. And of course there's a certain point where they're going over the limb, so they're a filament on the disk and a prominence on the limb. And I think this gives a really nice three-dimensional impression of what these things are. But just an amazing kind of quality of imagery that amateurs are getting. If near the beginning of this meeting we climbed up on the building, on the roof of this building and seen moonrise, we might have been lucky enough just to see the end of a total eclipse. We'd have seen the very last partial phases of it. But this meeting is far more interesting than going up to see the end of a partial eclipse, I think. But since our president is now, in his very words, from the dark side, I thought I'd start off the Sky Notes with some mention of this object, the Moon, and the things that it's doing. And there are a couple of interesting things coming up. Typically they involve stuff going behind the Moon rather than the Moon itself. But there are a couple of interesting occultations coming up, and the reason that they're interesting is because they involve multiple stars. So normally in occultation the star flips out or comes back instantaneously. With multiple stars you actually see a fade, either up or down. So this one is worth looking out for. This is 2341 on tonight. So if you can get home through all of the London Christmas shopping crowd and it's clear, this one's worth looking out for. Over most of England this should be seen. It's a reappearance of a bright star, Mag 5 or so, and the almost full moon, which of course is tonight. There's another one of these in a few days' time on the 14th. This one is Alpha Cancri, which is a triple star, which will be even more interesting to watch coming out. Again, it's a reappearance, Mag 4.3, around 10 o'clock at night on the 14th. So if you happen to have a clear sky on the night of the 14th and the moon's in the sky and you can't do any deep sky observing, this is the kind of thing that you might want to have a look at. This would be visible in binoculars, for instance. So starting out going through the night sky from basically sunset, this is basically what we're seeing at sunset. The planet that's furthest over in the west is Uranus in Pisces. And Uranus has actually had quite an interesting event recently. Uranus is a pretty bland planet and a pretty small planet, about less than 4 arc seconds in diameter. Extremely difficult to see any detail on the surface of Uranus with amateur telescopes. But if you're lucky enough to have an 8-meter telescope, it just happens to be in your back garden, you can see stuff. And this was actually observed on Uranus in the near infrared back at the end of October. This is surmised to be a storm in Uranus's atmosphere. And it's one of the brightest storms that's been seen on Uranus for a long time. And so amateurs were encouraged to go out and observe the planet to see what they could see. Now, bearing in mind Uranus is such a small object, it's extremely difficult to see stuff on that planet. But here are a couple of drawings by 2 observers. One here this is by David Gray with a large Dal Kirkham. This one by Paul Abel with a large, that's a Dal Kirkham as well. So a telescope specially designed to have very good definition and detail on planets. And if you kind of squint your eyes and screw them up a bit, you think there may be some brighter area here in this belt. Very, very difficult observation to make, but I encourage anyone, Uranus is still there in the evening sky, go out if you've got a decent telescope, have a look at it and see what you can see. But this is not the kind of thing that you're going to see in any sort of small to medium-sized telescope. You need a large scope and you need very good seeing to see this. I don't know whether anyone in the audience who's a planetary observer has actually seen anything. Patrick's shaking his head. No. Very, very difficult thing to see. So moving on to a much bigger planet, Jupiter's still there, still the brightest object in the sky, probably the cause of a lot of Star of Bethlehem or UFO things over the Christmas period. But Jupiter's been showing some absolutely spectacular detail recently. It's high up, so the seeing is very good. It's worth a look at even with a small telescope. But if you happen to be somebody like Damien Peach, and you happen to be based in the perfect observing site of Chelsea, then you can achieve this kind of thing. So this again shows, here's the red spot. The two equatorial belts are back but look very different, and you've got these really dark barge features. And Damien sent me this, which is just an awesome movie that he put together from some of his best 2011 images. And you know, seeing this kind of thing just makes you amazed and in awe of what amateurs can do with 14-inch telescopes, particularly Damien Peach. But you do need to be in Chelsea to get this kind of quality. Going round then, later in the evening now, we've got, of course, Orion is the main winter constellation is visible now. But rising low in the east is Mars. Mars coming around to be much better early in 2012. But observers are already getting images of it. Here's some that were taken basically at the end of November. The disk is still quite small, quite a lot of detail though still visible, and the northern polar cap clearly visible and very prominent. Going round still further into the morning sky, we've got Mercury rising basically towards Christmas. Mercury will be rising in the morning sky just at dawn. But we also have Saturn. Saturn's coming back now. Unfortunately, Saturn's been moving further and further south in the sky, so from our latitudes it's a more difficult object to get good images. But the storm that was there last year is still there. This is a fairly early image now from Japan, and this thing here is the North Tropical Zone storm, which was a big storm last year, still visible. So again, Saturn's still an interesting object to look at, but it's moving south, so more and more difficult. In the field of asteroid occultations, there's this interesting one. This is coming up on the 17th of December. If you happen to be in the southwest or Wales or Ireland, this is a good one to look out for. It's a big magnitude drop, 6.7 magnitudes, fairly short, only 2 and a bit seconds. But there are lots and lots of these asteroid occultations around. There are various websites that you can get predictions for these. Tim Hames manages this for the BAA, and if you're interested in observing these, contact him, because he's always on the lookout for people around the country who can actually observe these either visually or using electronic means like CCD cameras or TV cameras. And the big advantage of this is that by timing the time that the star disappears behind the asteroid from various different sites, you can get really good information on the size and shape of an asteroid, which is very difficult to get in any other way. Now, a tale of two spacecraft, just quickly, because Mars is coming around. Of course, we're at that launch window when people send spacecraft off to Mars, and two spacecraft have recently been sent off to Mars, potentially. One of them, this one, is a Russian spacecraft with a Chinese microsatellite on it. This one's called Phobos Grunt, which means Phobos soil. And the idea was it was going to go to Phobos, land on the surface of Phobos, pick up some of Phobos, and bring it back. It's an extremely challenging mission, which the Russians had high hopes for, but unfortunately, Phobos Grunt ended up in Earth orbit. The Russians, unlike the Americans and Europeans, tend to launch their planetary probes first into a parking orbit, and then they have an upper stage that pushes the probe out to the planet. Phobos got into orbit fine, but its upper stage didn't fire, and it's currently stuck there. And these are a couple of images. One of the one is that I've taken here. So this is a trail of Phobos Grunt. These are aircraft. And this one that Richard Fleet took. And you can see that the spacecraft is actually changing in brightness quite rapidly. This is only about a minute from here to here. It's moving very fast across the sky because it's so low. The fact it's changing in brightness means that its attitude must be changing, it must be tumbling. So there were some attempts to communicate with it, but pretty much now I think everyone's lost hope, and the next big thing for this spacecraft is re-entry, which will probably be sometime in January. It comes over here quite regularly, so we might get a quite spectacular re-entry to observe. It's got a large mass of hydrazine on board, so expect the media early in January to start coming up with lots of scare stories on the re-entry of that. The other spacecraft was this one, Curiosity Mars Science Lab, and this one was launched successfully on an Atlas V, and this one is actually on its way to Mars to drop a rover onto the surface that's about the size of a car. It's going to be an incredible achievement if this thing actually lands, a huge rover. So we'll see how that goes, but a very successful launch using an Atlas rocket, which interestingly uses Russian rocket engines. It's an American ICBM that now has Russian rocket engines on it. So not all bad for the Russians. The Russians are very good at rockets, it's just their spacecraft to the planets haven't been very successful. Coming up in December in a few days' time is the maximum of the Geminid meteor shower. Definitely a meteor shower worth going out and observing. The only problem this year is that we've got a bright moon in the sky not far from the radiant. So the best time to look with the moon out of the sky is probably in the early evening of, say, the 13th, 14th, 15th, 16th of December, something like that. The radiant is going across here, but it's basically near Castor and Pollux in Gemini. The rates can be quite high. They can be sort of upwards of 100, 120 meteors an hour. But because the moon's in the sky, probably going to be a difficult shower to observe this year. The other shower at this time of the year is the ones for the really hardy meteor observers. It's the quadrantids. It comes from a place here, which used to be the old constellation of Quadrans Muralis, which doesn't exist anymore. It's basically between Draco, Boötes, Hercules and Ursa Major. Now this has quite good rates as well, but it tends to be a rather under-observed shower because it takes place early in January in the small hours of the morning. So it tends to be cold and fairly sort of hardy people are needed to observe it. But definitely worth going out and having a look for the quadrantids. Again, ZHR maximums of maybe in the 80 to the hundreds. So that's early January. Now, there was a report a couple of days ago now of a very bright fireball that was seen over the southeast of England on December the 7th, that was Wednesday night, at around 10 past 4, 7 minutes past 4 in the afternoon. Apparently this was brighter than the moon. It left a long train that looked like a vapour trail. It was visible from certainly the east and southeast of England. And John Mason would be interested if anyone saw it or anyone knows anyone who saw it or anyone sees anything in the media to collect reports on that. Unfortunately at the moment we have no images of that one. But I'm just going to spend a few minutes now talking about some work that I've been doing with Peter Meadows and some people down at the Norman Lockyer Observatory to set up a fireball detection system across the country. And we're using various different ways of detecting these fireballs. We have a high sensitivity video camera, we have a CCD camera that takes stills, and also the Norman Lockyer Observatory are using backscatter radio detection from using a transmitter source which is in France, which is called the Graves radar. This is a radar that's designed to pick up spacecraft in orbit around the Earth, but it broadcasts high power radio signals up into the sky which can reflect off the ionized trail of a meteor. And they have receivers around the country which can detect these reflections and calculate all sorts of interesting parameters about what they've detected. So we've had some interesting results where we've got simultaneous detection both in video, still and radio, and I'll just show some of them here. This is during the Leonids. Now that was a fairly small fireball, but just to show you what kind of things you can detect. The next one was in thick fog. Now that fireball probably reached, it's difficult to tell because of the saturation, but it probably reached something like -13 magnitude. Very, very bright fireball. It was detected by Peter's still system, and very interestingly it had a long-lived train, which you can see in these images. So these images are 10 seconds apart. So what you're seeing here is effectively the ionized train of the meteor gradually being distorted over time by upper atmospheric winds. And you can see even here something like getting on for 3 minutes later, it's still there. Now Norman Lockyer Observatory detected this. Now what you're hearing is the audio of their detection. So what this is a radio signal being reflected off that ionized train. So on this plot here, intensity is up this way, time is along here, and this axis is showing Doppler shift. So what this is showing is the velocity of that ionized train relative to their receiving station. So with the system we've got now, we're actually detecting a lot of these objects and trying to work out really what to do with the data, but there's a lot of interesting stuff in there. And the cameras that we've got running now, running throughout the dark hours. Unfortunately, this fireball on the 7th of December occurred just after sunset, and my camera doesn't start until the end of civil twilight. So it was about 20 minutes after the fireball went by. Just going over to the things that are causing all of these meteors and fireballs, that's comets, and there are two comets which are interesting not because they're visible from here, but because they've been discovered by amateurs. These days most comets are discovered by amateur surveys, and those amateurs, by professional surveys, and those professional surveys pick up comets when they're very faint and very far out. We've had two amateurs picking up comets, and both of them were picked up in basically the holes in the survey. So this one, Comet Hill 2011 W2, was discovered at 18th magnitude in Canis Minoris. Here's an image of it by Denis Brzezinski. It's a fairly faint comet, and it's fading and moving away, but interesting because it's an amateur discovery. The very next comet was discovered by Terry Lovejoy in Australia, and this is a particularly interesting comet. This was a comet he discovered in the twilight sky, the area where the surveys don't really look. It's a very small comet, but it looks like it's what's called a Kreutz group comet. That is a comet that's going to go into the sun. It'll be a sun-grazer comet. There it is in an image here. It's brightening reasonably, but it's in the far south. So again, we can't see it from here. But if you look at the SOHO satellite webpage, they have every image from SOHO satellite being updated. And it's predicted that sometime around December the 14th, the comet will enter the SOHO field of view. And it could be one of the brightest ever comets to enter the SOHO field of view. Various estimates for the magnitude at the moment, but maybe -3, -5, something like that. Extremely difficult thing to predict though, because it's a comet that's only been observed over a very, very short arc. But definitely worth looking at. So it's a comet you can observe from the comfort of your own laptop. Just before I talk a little bit more about comets, I wanted to show this. This is one of the most northern outposts now of the BAA comet section. This is Denis Brzezinski's observatory, which is in a place called Port Mahomet, which is up on the northeast coast of Scotland, north of Inverness. He's got two telescopes there. He's got a C14 in here, and he's got a smaller telescope in here, and as you'll see in a minute, he has an absolutely fantastic horizon for doing comet observing. So basically he's got sea on three sides. He's between the Moray and the Dornoch Firth, and he's got that kind of horizon, which is perfect for comets, because over in the east, comets coming up near the sun. So Denis has taken on the role within the comet section now to receive your observations of comets. I sent out an e-bulletin recently. The email address for this is called cometobs@britastro.org. So any observations of comets that you have, if you send them to that address, and Dennis will respond and will archive those images. And the comet that we're particularly interested in at the moment will come after this one. Sorry, there are two comets in the sky that are moderately interesting at the moment. There's this one, which is Comet Hill. It's visible in the evening sky. In a telescope, it's got a reasonable tail. It's not the most spectacular of comets. But then there's this one, which is Comet Garrod, which has been around now for quite a while. It's been brightening up, and it's still brightening. And it's over in Hercules. It's moving very slowly up through Hercules through the next month or so. It's reaching a magnitude probably of about magnitude 7 or so, possibly even brighter in the end of January, February next year. It's worth a look. It's got a nice gas tail, a nice dust tail. It's visible easily in binoculars from a dark site, and it's a nice CCD target. And the interesting thing about it is that it moves, it's moving a long way away from the ecliptic. So over the next few months or so, it moves up to a very high northerly declination. Now, this plot is actually come from our computing section. A guy called Graham Ralph has been doing these, and if you go to the BAA website, you go to the computing section, you can actually now ask it to produce charts and plots for any object that you're interested in. It'll give you the observing circumstances like this. So what we've got here is we've got the sun at either edge, we've got the midnight meridian here, and basically you can see where the moon is, you can see where the object is you're interested in. So it can very quickly give you an overview of what's visible in the sky. Definitely worth a visit. And this is basically what the comet's looking like now. Say there's a dust tail, a gas tail, and quite a nice coma. It's the best comet we've got at the moment. Definitely worth going out and have a look at, and if you do get any observations, send them in to the BAA. And then finally, in terms of objects worth looking at, everyone knows this. This is the Plough. At the end of the Plough is a very nice Messier galaxy called M101. And in M101 is a supernova called supernova 2011 FE, which is this object here. Now this was discovered some while ago. It was quite a bright supernova, but it led to some bizarre media reports, including ones which said, if you want to see a supernova, go outside in the evening sky, look for the Great Bear, look for the tail of the Great Bear, and there will be the supernova. Well, this was like 10th or 11th magnitude in a galaxy. It's not likely to be something that you would just stumble across. But it's a nice bright supernova, but like all of these supernovae, a few months after they're discovered, no matter how bright they are, people stop observing them. And Guy was telling me earlier on that the number of magnitude estimates of this supernova have really fallen off. So it's definitely worth a look, it's definitely worth imaging or looking at visually and come up with some estimates. This is where it is at the moment. It sort of went up to a peak, brighter than Mag 10, so very, very bright for a supernova. And it's sort of plateaued out now somewhere around Mag 12 or so. So easily within the range of a moderate-sized telescope.